So this begins your second lecture on variables in measurement, material covered in Chapter 3. In this set of lectures, we're going to be talking about mostly two specific concepts, reliability and validity. Now, Jackson covers these again in Chapter 3 as well, but it's important to pay attention because there's a couple things we're going to talk about here that are not covered in Jackson, as well as a couple of differences in the way that the material will be introduced here. So what are reliability and validity? Before we talk about those, it's important to understand one important thing that we're going to be doing when we do any sort of research in psychology, behavioral science. Now, so far what we've done is we've learned to formulate our research questions. We've identified the different variables of interest, our independent and dependent variables. And we've also figured out some sort of operational definition for exactly how we're going to measure those variables in the context of our study. Now, one important thing to keep in mind is that there's always going to be some sort of error in our measurement of those variables. That is, we might have some specific construct in which we're interested. We've talked about quite a few of these: intelligence, or memory, or anxiety, or aggression, honesty. Whatever any of these might be, we're going to be trying to measure those through some sort of operational definition. Well, chances are we're never going to be able to have any real true measurement of some of these constructs. We might never know how honest somebody is because the accuracy of our measurement is going to be limited in some degree by the way that we're conducting this measurement. That is, by our operational definition. Okay, so whereas objective measurement is very hard to come by when we're talking about human behaviors and psychological constructs, this isn't necessarily the case when we're dealing with physical quantities such as in the natural sciences. Okay, but objective measurement, again, is very difficult to come by when what we're looking at is human behaviors. So what does that mean for us? Well, as long as we understand that there's always going to be some sort of error in this measurement, not error meaning that we've necessarily done anything wrong, but just acknowledging the fact that we're never going to be able to understand or measure the true value on some of these psychological constructs. Now, measurement error can be broken down into two different types: systematic versus unsystematic or random error. What we really hope is that we don't have any sort of systematic measurement error when we're recording our measurements. And that's what reliability and validity are really all about, as we'll see. In other words, if we're measuring something but we're systematically off in the way that we're measuring it, these are the types of errors that we are likely to have some sort of control over, whereas unsystematic or random error is going to be forces that are beyond our control. Okay, so in other words, there's always going to be some sort of variability, some sort of random error in our measurements that we're not going to have any control over, that we're not going to be able to do anything about. We're not going to be able to minimize or eliminate unsystematic error. But if we're always using some sort of systematic mistake when we're taking our measurements, these are the things that we can be aware of and hopefully reduce when we are making these measurements. So what we're trying to do whenever we're measuring psychological constructs is to try to, again, control this error, reduce inconsistencies. Because if we're measuring a construct incorrectly, we're going to ultimately draw conclusions about that construct, and in that case, we would be doing so incorrectly as well. So when we talk about reliability and validity, what we're really trying to do is to control for this systematic measurement error. We're going to try and reduce the inconsistencies and make stronger claims about the actual constructs we're investigating by trying to make sure that we're measuring them the best way that we can. How are we going to do that? We're going to try and increase two properties of our measurement instruments. We're going to try and make sure that our operational definitions are both reliable and valid. So what do these things mean? First, let's start with reliability. In essence, reliability refers to simply the consistency in our measurements, or the precision. Are the measurements repeatable? That is, if you step on the bathroom scale and it gives you a certain reading, then if you step off and step right back on it again, you hope that it's going to give you the same reading. If I step on the scale and it tells me 175 pounds, then I step off and step back on 3 minutes later, it tells me 180. I step off and step back on again, and it tells me 190. There's going to be something wrong with my bathroom scale. Those measurements aren't repeatable. They're not consistent. So reliability is really just another way to say that our measurements are going to be consistent. That if the construct that we're investigating has the same sort of underlying value, the true value, that we're going to be getting the same value every time that we measure it. Now again, we might be systematically off here, okay, and that's what we want to try and avoid. It might be a little bit of measurement error in terms of what we're doing. Okay, but we hope that it's not systematically off in any way. So again, reliability simply refers to exactly that, the consistency in what we're measuring. Now, in our operational definitions and measurement instruments, there's a few different types of reliability that psychologists and behavioral scientists are typically interested in. Okay, the first of these is, are our measurements repeatable across different instantiations? So let's say we've developed some sort of test to try and measure some sort of trait in somebody. Okay, and you can think about a popular IQ test or even the SATs or other sorts of aptitude tests. Or let's say we create a 10-item questionnaire that's supposed to measure anxiety or speaking anxiety, test anxiety, something like that. Okay. Well, one thing that we want is for our reliability or consistency across instantiations of our test. Okay. And this is going to be just like, again, stepping on and off the bathroom scale. What we want it to do is, if the underlying value is the same, say that my intelligence hasn't changed from week to week, then what I want to obtain is very similar scores on the IQ test on each instantiation each time that I take the test. Okay? And again, the name sort of points you directly at what this is looking at. This is called test-retest reliability. Okay? If we test somebody and then retest them, we want to achieve similar scores each time. Now, what we're also interested in is reliability or consistency within a single measurement instrument. Okay, and we can achieve this in a couple ways, but bottom line here, what we're looking at is, again, let's say that we have these 10 different measures, and they're all supposed to be pointing towards intelligence or anxiety or whatever it is that we're measuring. Well, then what we want is we want all of the items on our scale to be, if you will, equally well or equally adept at measuring that construct, such as anxiety or intelligence, whatever it might be. Okay, so I might have 10 items on my scale. If item number 3 measures intelligence, of course I want number 6 and number 8 and number 10 and every item on that scale similarly to measure intelligence. So whereas test-retest reliability is looking across different instantiations of a test or measurement instrument, what we're talking about now is looking at the different factors or the different parts within a single measurement instrument. Okay, and there's a couple ways to achieve this. The first is through what's called split half reliability. I might take my 10 items, look at just the first 5 and see how people score on those, and then look at just the other 5, see how people score on those, and I would hope that the measurements or that the total score that people get are similar across those 2 different halves. Again, as the name suggests, I'm going to split my test in half and look at whether or not the score on the first half is similar to the score I achieve on the second half. Okay, and that would be similar to if you could take your bathroom scale and maybe measure, your left foot and your right foot independently or something like that. Okay. The other type of within instrument consistency that we're interested in here for a reliability measure is simply called internal consistency. Okay, this one's a little bit more complicated to measure, but essentially what this looks at is how well all of the items point in the same direction. So rather than just looking at the first and second half of a test or instrument, or comparing, let's say, the odd items to the even items on a scale. Those would both be split half reliability measures. What internal consistency looks at is essentially looking at how well each of the different items on a specific scale are measuring the same thing as every other item on the scale. And again, we're not going to be interested in the mathematics of such a computation. We're talking in 1 second about exactly how these things are calculated. Finally, a lot of times, and especially in observational studies, as you guys are going to encounter in a few weeks, what you might have is measurement conducted by people judging something. Okay, so you might have some sort of construct in which you're interested. You might have several different people observing a set of behaviors. And each of these people has to indicate somebody's score or even whether or not they're performing a certain action. So if you're looking at altruistic or helping behaviors, several of you might be observing the same situation uptown or on campus somewhere, wherever your study is going to be taking place, and what you need to have is agreement among the different judges. This is referred to as inter-rater reliability. Okay, that is, are all the different people who are rating a certain behavior producing consistent scores. Okay, think about judges in the Olympics. What you hope is that if they're using some sort of consistent scoring system, that if one judge rates a gymnast or a diver or somebody else very highly, that all the other judges are going to produce similar ratings as well. Okay, this means that the judges are scoring things very reliably or consistently, that you don't have one rogue judge who's rating somebody very high or very low. Okay, this is what's referred to as inter-rater reliability. agreement among multiple judges. So you might see that all of these things are looking at, are we producing similar scores across different things, either across different instantiations of a test or instrument, either across the different items within a single administration of a test or instrument, or across different judges or observers who are trying to code or rate the behavior. Well, any of these sort of calculations can be done mathematically using the correlation coefficient. Now, we're going to talk about this again later this semester. I'm sure you guys talked about it in Statistics 261, because the correlation then tells us the degree to which different quantities change together. So in terms of test-retest reliability and split-half reliability, these sorts of things, inter-rater reliability, what you'd be hoping for is high correlations among scores across people on the first test and on the retest in the first case, or high scores across judge number 1 across all of the divers, with judge number 2 across all of the divers, and so forth and so on. Now, one of these, internal consistency, is typically measured with something called Cronbach's alpha. This is really just sort of a fancy calculation that what it does is it looks at the correlation between every single item on a scale and every other item on the scale and looks at an average of those. So in other words, I might look at the correlation between item number 1 on my intelligence test and item number 2, and then look at the correlation between item number 1 and item number 3. And then look at the correlation between item number 1 and number 4, number 2 and number 4, number 3 and number 7, every single one of those correlations. And then essentially what it does is average all of those individual correlations. So on average, how well or how reliable, how consistent is any given item on my scale with any other given item on my scale? Okay, this is by far the most popular method to compute a measure of internal consistency quantitatively. Again, it's referred to as Cronbach's alpha. It's based on the correlation coefficient, but it takes it sort of one step further.